In this lesson, we're going to discuss finding the midpoint of a line segment. The coordinates of the midpoint of a line segment are the means of the coordinates of the endpoints. So if we're given a line segment with endpoints of A and B, and we want to know the midpoint, we can simply add the x coordinates and divide by 2, and then add the y coordinates and divide by 2. So we have a good formula for the midpoint of a line segment. Now, a couple of concepts that employ the idea of a midpoint are medians and perpendicular bisectors. A median is a line that joins the vertex of a triangle to the midpoint of the opposite side. So picture this blue triangle right here. Well, if we were to join this vertex to the midpoint of the opposite side, so picturing this as the opposite side, we could say this is the midpoint. The median would be this line that cuts through the middle from the vertex to that midpoint. On the other hand, a perpendicular bisector of a line segment is a line that's perpendicular to a line segment and passes through the midpoint of the line segment. So these are two different concepts, each of which employs the idea of a midpoint. For our first example, we're going to do an example involving medians. We're going to find the equation of the median line from vertex A in triangle ABC if the coordinates of the vertices are -3, -1, 3, 5, and 7, -3. So you'll see we've put the appropriate vertices down with the coordinates. A is at -3, -1, B is at 3, 5, and C is at 7, -3. Now it discusses the median line from vertex A, so we're going to go from vertex A to the midpoint on the opposite side. And you have to keep in mind that this side length here is equal in length, this half of the line segment is equal in length to this half of the line segment. And we're going to figure out the equation of that red line. Well, the first thing we need to do is figure out the coordinates of the point. And you can see here the coordinates are 5, 1. But let's see how we can calculate that. What we do to get that midpoint is add the two x coordinates. So we're going to go 3 plus 7 and divide by 2. And why is that? Because the x coordinates in question were 3 and 7. 3 plus 7 divided by 2. And similarly with the y coordinates, we're going to add 5 and -3 and divide by 2 because the y coordinates in question were 5 and -3. When we do that, we get that the midpoint is the point 5, 1. Now we're going to use the method of y equals mx plus b. And we're looking for the equation of the line from -3, -1 to 5, 1. Well, using the y equals mx plus b method, we see that the slope is going to equal y2 minus y1 over x2 minus x1. That's equal to 1 minus -1 over 5 minus -3, which is 2 over 8, or 1 over 4. So the equation of this line is y equals 1/4 x plus b. In order to solve for b, we need to sub in either the point -3, -1 or the point 5, 1. So we're going to sub in the point 5, 1. Doing that, we get 1 for y equaling 1/4 of 5 for x plus b. So 1 is equal to 5/4 plus b, and we end up realizing that b is equal to -1/4. So the equation of the median from vertex A is y equals 1/4 x minus 1/4. And that makes sense because it looks like this red line has a slope of about 1/4, and it looks like that y-intercept is about at -1/4. Okay. For the next equation, we're going to find the, for the next question, we're going to find the equation of the perpendicular bisector of the line segment joining the points P and Q. And in this case, P is equal to -1, 4, and Q is equal to 3, -2. Okay? Well, we can see that the, just by eyeballing it, the midpoint is right about here, between these 2 points. And if we draw a line at a 90-degree angle, we get a right angle like that. What we're doing is we're looking for the equation of this red line. We call that the perpendicular bisector. So first we need the coordinates of that midpoint. Well, we add the two x coordinates We add the two y coordinates, so we divide each of those sums by 2, and we get that the midpoint is equal to 1, 1. So this midpoint right here, I'll erase that, this midpoint right here is the point 1, 1. And so now we're going to look for the equation of this red line, and to find the equation of the red line we'll need the slope and a point. We have a point, but we don't quite have the slope. But if you think about it, we can find the slope of this black line and then just take the negative reciprocal of that, since that's what a 90-degree angle line would have. So we're going to find the equation of this black line, then take the negative reciprocal and use that as the equation of the line that we're looking for. So the line segment PQ has a slope equal to y2 minus y1 over x2 minus x1, which is negative 2 minus 4 over 3 minus negative 1. Negative 2 minus 4 over 3 minus negative 1. That's equal to negative 6 over 4, which is negative 3 over 2. Well, the slope of a line perpendicular to that would be 2 over 3, the negative reciprocal. So that means that the line that we're considering, the red one, has a slope of 2/3 going through the point 1, 1. That means y equals 2/3 x plus b. Subbing in the point the x and y values of 1 and 1, we get 1 equals 2/3 plus b, which means b equals, I have negative 1/3 written here, but it's actually positive 1/3. So b is equal to positive 1/3. And so the perpendicular bisector in question is y equals 2/3 x plus 1 over 3. For the next one, we're going to try and determine the coordinates of point B if point A is at 8, negative 3, and the midpoint of AB is 9, negative 1. So diagrammatically, let's see what that would look like. We know that the point A is at 8, negative 3. B is somewhere up here because the midpoint is 9, negative 1. We're trying to figure out what are the coordinates of this point. Halfway from A to B would be the point 9, negative 1. Well, we can see that in order to go from A to B, we had to go right 1 unit, up 2 units. Or sorry, to go from A to M. To go from A to M, we went right 1 unit and up 2 units. So, since that's the midpoint, to go from M to B, we're going to go right 1 unit and up 2 units. To get from A to M, we move right 1 up 2. To get from M to B, we'll move right 1 up 2. Well, since M is 9, negative 1, we're going to move right 1 up 2. Right 1 means add 1 to the x-coordinate. Up 2 means add 2 to the y-coordinate. And so 9 plus 1 is 10. Negative 1 plus 2 is 1. And so the coordinates of that point, we go right 1 up 2, right 1 up 2. Add 1 to the x-coordinate, add 2 to the y-coordinate. The coordinates of the point are 10, 1. And that's what we have. Okay? Alright, for our next question, we're going to sort of employ the ideas behind midpoints, but a little bit differently. We're going to determine a point that's 1/4 of the way from the point C to the point D. Well, C is here at negative 5, 6, and D is all the way down here at 1, negative 12. And we're going to try and find this point A, which is a 1/4 of the way from C to D. Well, in order to go from C to D, we see that we have to go right 6 down 18. Okay, if we were to count these squares, it would be right 6 down 18. We would also get that by seeing that negative 5 plus 6 is 1, x-coordinates, and 6 minus 18 is negative 12, y-coordinates. We don't actually have to draw the diagram to come up with those numbers. Well, we only want to do 1/4 of that. So, instead of translating 6 right and 18 down from C, to travel to the 1/4 point, we're going to travel 6 over 4 right and 18 over 4 down. We divided each of these numbers by 4 to get to the 1/4 point. Well, moving to the right means adding to the x-coordinate. So we take our x-coordinate of -5 and add 6/4. Moving down 18/4 means subtract 18/4 from the y-coordinate. So we take our original y-coordinate of 6 and we subtract 18/4. Well, that would be -20/4 plus 6/4, comma, 24/4 minus 18/4. That's -14/4, comma, 6/4. And when we simplify that, we get -7/2, comma, 3/2. So the point that we were looking for, which was 1/4 of the way there, was -7/2, comma, 3/2. Okay, now, moving on then, we can generalize that a little further, and now we can find the 1/3 point. So this next question asks us for the coordinates of the point 1/3 of the way from C to D. So to do that, if it helps us to visualize, we can draw a diagram from C to D. And we're looking for this point B, which is 1/3 of the way, 1/3 of the way from C to D. Well, we're going to use the same ideas. Instead of traveling right 6 and down 18, we're only going to travel right 1/3 of 6 and travel down 1/3 of 18. So instead of traveling 6 right and 18 down, we travel 6/3 right, divide by 3, and 18/3 down, divide by 3. Well, 6/3 is the same as 2, so we'll be traveling 2 right, so that's like adding 2 to the x-coordinate. And instead of talking about 18/3 down, we'll talk about traveling 6 units down. And so we'll be going -5 plus 2, and then 6, I should have a minus sign there, sorry. We'll talk about traveling 2 units to the right, and so -5 plus 2, and 6 units down, so in the y-coordinate that'll be 6 minus 6, and we get to the point -3, 0. And when you look at the graph, that looks like the point -3, 0. So again, we don't have to draw those graphs, but a lot of times they're helpful in order to help us visualize and develop a strategy for how to find the right answer.